Hi, Dr. L. and fellow students. My name's AJ Haskins, and I'm presenting trichloroethylene, also known as TCE. Okay, so what's trichloroethylene? So some quick facts. It's organic, but it's also synthetic, so it's chemically made. It's a toxicant, colorless liquid, and it is volatile. It's moderately water soluble, highly lipophilic, or can get stored in fat, and denser than water. It can be called a couple other things, trichlor, trike, tri, and it's used as an industrial solvent, so it can dissolve and dilute other chemicals, such as in paints, adhesives, and paint strippers. It's a degreaser, so it removes grease and dirt from metal. It's used a lot in aerospace engineering, for example. It can be put in fungicides, pesticides, refrigerant. It can be used as a spot remover at dry cleaners. And I chose it because I have a strong interest in hydrology and pollution, and TCE uh, can get into groundwater. So I found this topic interesting. So there are two common routes of exposure for TCE, and those are ingestion from drinking water usually and inhalation. So inhalation can occur because TCE is highly volatile, so it volatilizes into the air. And so that can cause acute or chronic exposure, and that usually happens in the workplace because you're either working with high amounts, so that could cause acute exposure, or you're working with it often, so that could cause your more chronic exposure, especially if you're working with degreasers or industrial solvents regularly in an area that doesn't have a lot of air ventilation. And then for the more general public, you're more likely to ingest it through drinking water that was contaminated from a well. And this can happen through spills or discharge or leaching from hazardous waste sites. And TC has this ability to break through clay-like material, so it can move through soil pretty easily and then get to the groundwater. And then once it's in the groundwater, it integrates with it, and then it gets distributed to all kinds of places, including people's wells. So the mode of action or toxicokinetics for TCE, uh, for starters, it's known to be mutagenic, carcinogenic, and genotoxic, and I'll go over what some of those mean. So TCE was added to the 14th report of carcinogens in 2016, so that's when we officially started calling it carcinogenic. And according to the EPA, TCE has been shown to be positively correlated with causing kidney, liver, cervical, and lymphatic cancers. The reason why it can cause cancer is because TCE is genotoxic, which means that it damages cellular DNA, so that causes cancer. And then as opposed to cytotoxic, which we talked a little bit about, that means that the cells are fully destroyed. Um, and then TCE goes through this process of biotransformation in our bodies, and this is important for it being carcinogenic and mutagenic. So it's the body's way of changing a chemical so it can be more easily excreted, usually through bile or through urine. So there are two phases during this process. They're kind of complicated, but to simplify it, phase one is when TCE is catalyzed by an enzyme called cytochrome P450, and that leads to it being oxidized. Then during phase two, it links to glutathione in the liver or the kidneys. It can happen in either place or both. And then, according to this paper, the result from that is the metabolism results in reactive, genotoxic, or toxicological active metabolites at target sites in humans and in rodent test species. So essentially what this is saying is because the metabolism or this biotransformation is occurring in the liver and the kidneys, it then transforms the TCE into something more dangerous, and it's happening, in those two places. And so the chemical that you end up with is now in those two spaces, and that is carcinogenic. And that's why, like up here, I had said that kidney and liver cancer are like the top two. It's because it's metabolized in those two places. And then quantitative toxicology. So, according to an MSDS sheet that I found for trichloroethylene, the LD50 for rats through the oral route of exposure is 5,650 milligrams per kilogram. So, if I took this generic dose response curve here, where on the the x-axis, it shows the dose, and then on the y-axis we have the percent mortality. So if I were looking for how many, or the amount, the dose that had to be given for 50% of the rats to die, I would be looking for the 50% spot where 50% died, and I would drag it over to where it intersects with our line, and then I would drop down onto our x-axis to find that dose, and that's where they get that 5,650. And then they also did this for mice in a different source that I found, and they found that for males, the LD50 is 2,402 milligrams per kilogram per day, and for females, it's 2,443 milligrams per kilogram per day. I think that this makes sense, that it would be, the LD50 would be less for mice because they're smaller, so they're more vulnerable. Uh, they're more high, vulnerable to toxicity and to death. And so the fate of TCE is what I chose to talk about in our four options. So according to the TSCA, or the Toxic Substances Control Act, a substance is not considered bioaccumulative if the BCF, or bioconcentration factor, is less than 1,000, and TCE's bioconcentration factor is 100. And I speculated that this could be for a couple reasons. One, TCE is volatile and it evaporates quickly, so that doesn't give it much of a chance to persist or travel throughout the environment. It can be hard for it to reach groundwater, for example. Um, so, but when it does reach groundwater, it doesn't easily degrade. And that, once it gets there or in soil, it can persist for months to years. Um, and it can degrade in some anaerobic conditions where there's no oxygen, and it can degrade when it reacts with photochemically produced hydroxyl radicals. Hydroxyl radicals are produced during an interaction between sunlight and water. And when it degrades, it can degrade into other more harmful compounds such as dichloroethylene or vinyl chloride. Um, Another reason why it might have a low BCF is because the half-life of TCE is fairly short. It averages 7 days, but can range from 1 to 10 days. And trace amounts can remain in the body for up to 3 weeks. So it's a lot longer once it's in your body. And then, as I said before, for the biotransformation, it can also transform into other things in vital organs, thus causing cancer. And then the real world scenario that I chose was Camp Lejeune in Jacksonville, North Carolina. The drinking water at the most populated Marine Corps base on the East Coast was contaminated with TCE, DCE, tetrachloroethylene, vinyl chloride, and benzene between the years 1953 and 1987. This occurred because a dry cleaning facility just off base was dumping PCE onto the ground. And then over time, that leached into the groundwater. It was actually the dry cleaning facility that was cleaning all of the Marines' uniforms, interestingly enough. And one of the wells in the area tested as high as 1,000 parts per billion. And the maximum contaminant level that was set by the EPA is only 5 parts per billion. So these were exceedingly high amounts of TCE and PCE. And the spill resulted in many different side effects, um, some of them lethal, such as childhood leukemia. There was a cluster of breast cancer in men. There were neurobehavioral changes, infertility in women, spina bifida, lymphoma, and there was a specific birth defect that resulted in part of the brain or skull not fully developing in newborns. And there are actually a lot of people that are still filing for compensation because of this. who either live in the area or who were on the base. And it can be really hard to prove correlation and causation for these sorts of things. So it's sometimes hard to prove that this is the cause of their cancer. It's hard to say that they weren't gonna get that cancer anyway. So that's what a lot of these people are facing. They're facing illnesses and that are probably were caused by these spills, but they can't really prove it, unfortunately. So that's a grim note to end on, but that is the end of my presentation. And for Dr. L, these are my references from either journals or books. And then these are my sources from web pages, and I tried to be specific with the page numbers as some of these are quite long. And I thank you, students and Dr. L, for watching my presentation. And I will see you soon.